Thank you. Can everyone hear me okay? Awesome. I'm Kurt. I'm from the Microsoft Edge team, and today I'm going to be talking about enhanced text contrast. So you might be wondering, what is it? Well, it's two very specific things, and it's actually very simple. So it's an alternate formula for calculating text contrast that results in more contrast, and it's configurable values for contrast and gamma. And if that doesn't make any sense, I'll go into depth on both of those and explain why we might want to do something like this. So taking a step back, what do I mean by text contrast? Well, let's take some more steps back and just say text is super important for the web. You could kind of imagine the web render as like one of its main jobs is rendering text. Like Chromium renders tons and tons of text on a constant basis. And I'm relatively new to this space, and I've been learning that drawing text is much more complicated than I had imagined. If you all saw Dominic's excellent talk yesterday, that's had a lot of exciting things coming, and it's only really scratching the surface of what all is involved in rendering text. And so at a super high level, you have font files on your system or provided by the website that are vectors, and we have to display them. And so that means we turn them into pixels. That process is called rasterization. And this actually has a lot of code involved in rasterizing text. And with a lot of code comes a lot of trade-offs with performance, visual clarity, the code architecture. It's just a very, very complex thing that I always kind of took for granted. Being in layout and accessibility, text just always worked and worked very well. And so the rasterization process has quite a few inputs. This is actually not even all of them, but obviously it's going to need like the text color, the glyphs that I talked about, some information about your display, like resolution and things like that, and then a few constants, some kind of formula for contrast, bunch of other formulas as well that I'm leaving out here, and then there's this whole area of anti-aliasing, and I'll talk about that too as well. But today, it's really easy. I'm only talking about 4, and 2 of them are constants, which makes it very easy. One is a very simple formula, and then anti-aliasing is just a few different types that I'll talk about a bit and discuss why we might want one type over another. And so why would we modify this? Chrome is great at rendering text. I'm sure we're all aware. We read lots of text, and we're used to reading text in Chrome, and it looks really good. But something big happened in 2020, which is Edge switched its rendering engine to be Chromium-based. And us on the platform were really excited about this. Like, we were expecting this to be just a net win for customers. We weren't really expecting any people to complain about this. Like, this was generally considered to be a good thing. But we got a lot of feedback that users were saying text doesn't look as good. They were saying, hey, old Edge looked a lot better than this. What happens? And so we took this very seriously. It was kind of a surprise. And since text is so important, it was like we couldn't really ignore this. And we did see a concentration in CJK locales, so China, Japan, and Korea, where they have kind of more intricate characters, were reporting more of this. So big region of the world was saying, hey, it doesn't look as good, which wasn't a good thing because we wanted everyone to jump on the new browser. We basically made a bet on Chromium, and this was like very surprising that this key thing was generating so much feedback. And so why did this happen? I mean, the short answer is we went from millions of lines of code in one code base to millions of lines of code in another code base. There's obviously going to be differences there, but the real answer is that the old Edge used DirectX, in particular DirectWrite, for basically everything involving text. And Chromium uses Skia, which is kind of a hybrid. It does use DirectWrite for some things, but not as many things. And so that's one of the big reasons for the difference there. But like, what can we really do there? Like, Chromium is very tied to Skia. It wasn't really feasible to, use DirectWrite like we did in the older Edge with the new Chromium-based Edge. And so one of my colleagues, Ian Prest, was in charge of this project. He, obviously ruled that out because that, Skia is great. We don't want to lose that. And so he did make some really good observations, though, which is that formula for contrast I mentioned is subtly different between DirectWrite and Skia. And then the other thing is that Windows has some settings to change what text looks like. And those used to be applied in our old non-Chromium Edge, and they were no longer getting applied. So for users who cared about text and tweaked this, it was just getting lost. So I think those were very compelling. I did actually, looking through the Skia code, I did find that they were actually querying for these values, but it's behind a compile time flag. It's kind of just dead code. And so I'll explain why in a minute. There's actually a good reason for that. So Ian came up with a pretty good solution, which was to basically change the text contrast formula to be closer to DirectWrite's formula, to give it a little higher contrast value for text. And then he got those contrast and gamma values that are configurable on Windows, but not in Skia, and plugged them into Skia. And so very, very simple. This was enough to kind of end our users from complaining about text looking better. A bit of a caveat there, we didn't get that massive A/B test between platforms again. And the other thing is the idea was to bring this upstream into Chrome, and it's not currently, so I'll talk about that as well coming up. But this is the clear type tuner I talked about. Might be hard to tell in the projector, but each square is a little different. It's like kind of like an eye test. But if you were to like pick this and for instance pick the thickest one, it would apply everywhere in Windows except for Chrome currently, and it didn't previously work in Edge before this project. And so this is what it does under the hood. It just sets some registry keys. You can see one of them is the enhanced contrast level, so that's where the name of this whole project came from. But anyways, yeah, so that's pretty straightforward. You might be wondering, does anyone actually use this? Like, I had never heard of this. I was pretty skeptical that this would be a significant amount of users, but fortunately, he added some telemetry into Edge as well to see how many people had non-default values. And it turns out, yes, like 3% of our top level render frames had non-default values here, which was kind of shocking to me. I thought it was going to be like an order of magnitude smaller. And so it's top level render frames. So heavy tab users are going to skew this more. I have some theories about this, but haven't got any clearance as to why this was so high. But yeah, curious what Chrome's numbers are for this. You know, would love to add some telemetry to get that. I would imagine, I mean, on Windows, it's going to be somewhat similar. I don't see why it would be drastically different. But yeah, that was kind of a surprise. And, you know, could have accounted for a good degree of the feedback we were getting. And then so that was kind of the one half of the contrast and gamma for ClearType. This is the other half of the feature, which is how do you read these contrast and gamma values? Well, it turns out this is the Skia code I mentioned earlier. It's only a few lines of code. You don't have to read the registry directly. There's just these dwrite rendering params, and you can see get enhanced contrast, get gamma. It plugs them into Skia, but unfortunately this doesn't work. I tried removing that pound defines, which isn't defined anywhere. So it's been dead code since 2014 in Skia. And the reason is the Chromium sandbox. This makes a system call, which is not allowed at that level. So it completely fails. Ian's solution was to query it from the browser process and basically plumb it all the way through into Skia, which was not super straightforward. It's just plumbing, but it's a lot more levels than you might guess. And then this is the other half of the feature, the alternate contrast formula. The top one is the current one in Skia. Pretty simple. Takes 2 floats, returns a float, some adds and subtractions, and nothing too fancy. The DirectWrite inspired one is the bottom one. It's called experimental contrast. I'm not quite sure where that name came from, but you can see they're pretty similar. And so I have it graphed right here through the range of 0 to 1, which is the valid values here. The red one on top is the existing formula. The blue on the bottom is the enhanced formula. You can see they're very close to 0, and then they kind of diverge around the 0.5 mark and then converge again towards the end. So they're not drastically different, but they do render text differently. Interestingly, the experimental formula is producing lower values here, but somehow that produces more contrast. I'm not quite sure how that works, but maybe a font expert will know that a little better than me. Here's some screenshots. I'm not quite sure how they'll work on this display, but it's very hard to tell just looking at some of these characters. But I have a diff on the bottom where you can see like the edges are quite a bit different here. And so that's kind of what it looks like in practice. And then that's what the formula looks like in practice. This is what the contrast and gamma values look like. On the right, I have what it is today in Chromium. On the left, it's just maxed out. It kind of looks terrible, but I just wanted to demonstrate how flexible these are that are really not being applied today at all. And so the current status is like we intended this from the get-go to be upstream in Chromium and Skia. There was kind of it kind of stalled for a while, and so we said, hey, let's experiment downstream and just make our users happy, and then go back to Chromium folks and try to get this re-engaged. And so that's kind of where it is right now. Like, I would love to contribute this upstream. It's released to 100% of users for our experiments as of 2022. We haven't gotten any negative feedback. It hasn't caused any surprises or anything. It's pretty straightforward. But there is a big gotcha here with diverging and text rendering from upstream Chromium. Turns out there's a lot of master image-based tests that have text in them. And if they're off by the diff I showed earlier, they're going to start failing with this. And so we could fix all of the existing tests. Like, that's not the big problem. The real problem is any new test is just going to start failing. So again, I think this would be in its best shape upstream in Chromium. We could also disable this feature entirely for testing, but then we're not reflecting reality. So it's just a bunch of kind of bad trade-offs for us until we get this upstream. So we'd definitely love to get it there. And so I'm bouncing back and forth between these two things because they're pretty, they're both pretty simple, but these are the contrast and gamma values. In Skia, you can see their compile time flags per platform, so they're just not configurable at all. And they're slightly different values. You can see it says to approximate the system browser, but this is basically why those clear type settings weren't getting applied. Like it's, Skia just basically says contrast and gamma for text are fixed per platform with no way to change that. And Windows expects these to be adjustable. And so I wanted to bring up performance. This isn't a performance feature at all, but there are some interesting performance scenarios that I think this might enable. So it should be pretty clear this is performance neutral. The contrast algorithm is not anything more complex or anything. We only need to query the registry once. It's not something that users are changing constantly. So you wouldn't expect this to impact performance at all, right? But there is more to text rasterization than just the contrast formula. The type of anti-aliasing is one of these inputs, and it actually has a huge impact on performance. So before I go forward, I'll talk about anti-aliasing for a minute. It's just a general graphics term of adding like noise or blur to rendering, which counterintuitively makes it look clearer. It's a general graphics thing. It's not just for text. You might have seen it in games in the settings to like turn off anti-aliasing for better performance. But you pretty much always want this with text because it looks terrible. I would definitely not want to be reading text on the web like that. So we always have it enabled, but those different types of anti-aliasing are where the performance gains can come from. So so this is from Wikipedia. Might be hard to tell. It's decent enough to tell. So this type of anti-aliasing called subpixel. It's called subpixel because a pixel has 3 stripes, red, green, and blue. Subpixel will use one of those or 2 of those to get like a fraction of a pixel. So you can see in the bottom, you get this kind of rainbow effect when you zoom in. Clear type is similar. It's also using different colors there for the anti-aliasing, but looks a little different. And then you can see this last one is just called anti-aliasing. It's what's referred to as grayscale anti-aliasing. So it uses whole pixels of equal values of red, green, and blue. And so that's where the performance benefit comes in. I was told by PM, like, oh, if we switch to grayscale anti-aliasing, there's this amazing performance boost. And I was kind of skeptical, but I looked into it a little bit, and I found that on Android, it's the only anti-aliasing behavior supported. So it's not like it's like a net loss. Like Android renders text just fine. And so as for performance, I was actually really blown away. I forced grayscale anti-aliasing and ran some pinpoint jobs. This one is speedometer. And you can see one of the cases got 30% faster, which I was kind of shocked. There's another one, 8% faster. Like this was kind of mind-blowing to me. I did not expect this to be this big of a difference. I chatted with Dominic yesterday. He said that this does enable a few other optimizations, but this was kind of mind-blowing. Like I think any feature would be, would love to have that kind of speed up. There's also even more in the compositor latency. This was, I believe, the Blink paint tests. And you can see an 84% reduction. Oops, I went back. You can see an 84% reduction in compositor latency, which is also kind of mind-blowing to me. Also easy double-digit gains in all of these benchmarks. So I have a lot of questions about this. It seems almost too good to be true. So definitely would love to chat with some folks about why this might be different in Pinpoint versus real users. But if this is the case for real users, like I think we really should drive this to make this happen. And so this is really the code change I made. You can see on Android, this is always off. Mac, it's conditional. And then Chrome OS and Linux and Windows have this on by default. And so you might be wondering, like, hey, has anyone looked at changing this previously? Because, hey, there's a bunch of performance on the table. Well, the Chromium team did a really great user study in 2020 to see if they could turn this on just for these perf gains. I don't know if they had these specific benchmarks run, but they were aware that it's perf positive to switch to grayscale anti-aliasing. But unfortunately, that study, it showed the users did greatly prefer the RGBA subpixel anti-aliasing by a fairly wide margin in some of the cases. And they also came to the conclusion that the impact is more noticeable on lower resolution screens. Android, tends to have high pixel density because it's smaller screens, and phones really do, keep increasing the resolution. And I'm really curious if the same thing has been happening in the PC space since 2020. I mean, I know, there are a lot of devices sold in the last couple of years, so, maybe that's less of a factor now. But I also do think that enhanced text contrast makes this quite a bit less noticeable. And so I have some examples here. Hopefully you can tell, I don't know. But the top picture is on the left is the clear type rendering, the clear type anti-aliasing, and the right is grayscale. I can kind of tell the difference on a laptop screen between the two on the top. At the bottom with more contrast though, it's actually quite a bit harder to tell the difference in my case. And then I'll show some more examples here as to what these things do to the rendering. Most folks probably haven't seen this because Skia is very hard-coded on these kinds of things. So it is kind of interesting to see what the impact is. And so this was one of the test examples that fared particularly poorly in the user study that Chromium did. I think this was 90% preferred the top one. And I can tell the difference on a laptop screen on the projector, not really. This is it with enhanced contrast. It makes a slight difference there. And then this is with the contrast and gamma increased quite a bit just to kind of see how much we can tweak that. And this is kind of a happy medium. This is with grayscale anti-aliasing, with the enhanced contrast formula. And it's like I picked a slightly higher contrast and gamma value than normal. But I do think these both look really good. I would be extremely curious to do another user study with trying out some of these values to find something that will get us a happy medium that users won't be upset at losing their current text rendering. So yeah, it's my hypothesis. I think we can really, we can make this RGBA anti-aliasing work and get those perf gains if we do this. And at the very least, I do think that moving the contrast and gamma to be user settings, or at least user configurable and not fixed per platform, will be beneficial to users. At least on Windows, this is something that is expected to change. I believe you can change this on Linux, but even having something in the browser UI like that clear type tuner might be a reasonable option if folks really care about this. And so I have some work in progress PRs up. They're probably pretty out of date. I haven't touched them in a while. I know they have some merge conflicts, but I think that the design needs to be discussed and kind of figured out and get kind of an end-to-end customer scenario here figured out, and then get them landed. It's not much code. I've basically showed the entire thing in this slide. It's one half is that formula, the other half is getting the contrast and gamma, and then a ton of plumbing to get those values into Skia. I do think in general, making these values configurable in Skia would be, and more values in general would be beneficial. I noticed that a lot of things in Skia are kind of fixed. And I know, I've worked a bit in DirectWrite, and I know that has just a ton of configurability. There's obviously trade-offs with that, but I do think that's kind of an observation I've had on Skia. And yeah, just to wrap up, I think the performance gains of the grayscale anti-aliasing are just too good to ignore. I think the Chromium folks were doing the right thing by investigating this. I can also understand at the time why they wouldn't have picked RGBA, but I do think that things have changed in the last couple of years, and I do think that experimenting with this kind of stuff can really get some big wins for our customers. So that was everything I had. Was curious if anyone had any questions or.
Okay, we'll start with one from the audience here.
So this is David Barron. I think one of the things with the subpixel anti-aliasing is that you have to change some of the compositing decisions, because if you're using a 32-bit surface where you have RGB and then just a single alpha channel, you can't render subpixel AA text onto a transparent background, because fundamentally representing subpixel AA text on a transparent background requires that you maintain separate alpha channels for the red, green, and blue channels. In theory, you can fix that by rendering onto a 48-bit surface where you have RGB, AR, AB, AR, AG, and AB. I think Shenzhou was doing some investigation around that. I don't know what the state of that investigation is. I do see 2 hands up on the screen from people who might know some more about that.
Yeah,
I'll go first.
Yep, go for it, Robert.
Oh, I was saying Philip should go first to talk on that.
Hello there, I'm Philip. So I can talk a bit about a few of the things here. David Barron is exactly right about why this leads to the performance gain. It's because we can enable threaded compositing. You can't do that without this change. We have an active project right now called raster inducing scroll, which should get a lot of this benefit that you're talking about. The idea here is that we can make scrolls threaded, not composited, but threaded. And that should get most of the gain on all platforms, hopefully. But that doesn't mean that this isn't good as well, because this still improves text quality, still lets us do composite scrolling in cases where just threaded scrolling isn't enough. So I think it's a great change and great investigation. Also, some of the data we had previously, macOS disabled anti-aliasing. So we actually have some data from a national study where we were able to essentially do this project on macOS. And yeah, it's a killer project, really good for performance.
Yeah, my intuition around what's happening is that as each platform gets to a standard display density that's high enough not to need subpixel anti-aliasing, like they're able to turn that off and not have users notice the difference as much. Because like I think it was lost a bit in the presentation, but by doing subpixel anti-aliasing, you are effectively tripling your horizontal resolution for monochrome or grayscale text rendering whenever you're doing white on black, black on white, gray on white, whatever. And you can't get that back just by improving or by tweaking the color values in a non-subpixel manner. But if we can make grayscale anti-aliasing good enough that like text is still crisp and readable, and we have on average higher density displays than we used to, then maybe we can get to a world where we can turn that on as the default and people will be happy.
Yeah, I think in general, it's one of those features where it's like not much code, but it's so important and sensitive that we definitely want to be careful in what we end up doing. And definitely, it's something that people will notice if we don't get it exactly right. So definitely, yeah, definitely appreciate the input. And yeah, would love to chat with both of you sometime soon about this.
Okay, we have another question from the audience.
Thanks for the talk. You had mentioned that there was some feedback from users, and you said that you had about 3% of users with non-default clear type settings. Do you know if the feedback is mostly from those users with clear type settings non-default, or do you have that feedback on default settings as well? Or do you know, is there a correlation between those or not?
That's a great question. I wish we had that data. So we added the telemetry later, and so at the time we couldn't correlate the feedback to the telemetry. But yeah, that's a great question. If we could have correlated those two, I think we could have answered this, very, very, clearly and scoped.
Right.
But yeah, at this point we don't have that.
And just a quick question regarding Robert's comment that like generally I think that yes, the main displays for many platforms will improve or has improved already. We still have scenarios where external monitors are connected or secondary displays, or for example, as you see now, the projector is very different from your main display. So on these not so high DPI devices, we probably still need it.
And yeah, I think the other piece is, yeah, it's a very blunt, on-off switch. And so another option too is like, hey, we find these kind of scenarios where we, do need to use the subpixel anti-aliasing and, make it a little more dynamic. Might be another route here too for this feature.
All right, I believe that's all the questions. Thank you very much, Kurt.